Monday afternoon for the Sukur CVI Workshop. And in this presentation, we'll be reflecting out of the description of the climate science that you've just heard from Dr. Etua and had discussions about. And we'll look at how we're going to apply those ideas within the CVI workshop for the climate stressors. Once again, I'm Scott Heron. It's great to be with you this afternoon. What you see on the screen before you now is a series of key climate stressors that we have compiled from a number of different sources that we've identified as being applicable to a broad number of natural, cultural and mixed World Heritage properties. And so importantly here, we do not expect all of these to relate directly to Sukur Cultural Landscape. However, we were looking at the over 1,100 World Heritage properties as we were compiling these different lists. And some of these will be relevant for other World Heritage properties. Down the left-hand column, you'll see a high-level category into which each of these different climate stresses are connected. The first of those is temperature-related climate stresses. I'd like to draw your attention just to that red row, the temperature set of rows there, and ask you to come all the way over to the right-hand column, because here you'll see that we've defined a time frame over which temperature stress can occur. And one of these definition words is chronic. That's a long-term, a slow-moving but continual persistent stressor. And the second of these is the acute. That's a short-term or a pulse event stressor. So a very specific period of time over which stresses would occur. And you can see the names of these two stressors over here in this column. The first one, the chronic time frame, the long term, is described as a temperature trend. Now, obviously for Sukur, we'll be talking about air temperature trend. But we can also have specific events, extreme heat waves, extreme periods of temperature. And so they can also be extreme cold events, I should point out also. So this is events that are unusual because they are either unusually hot or unusually warm compared with normal conditions. So I'm painting this story very carefully in the hope that you're coming along on the journey here. We want to consider temperature in two ways: long-term changes and short-term bursts, because those can have different effects on the World Heritage values and on the community associated with the property from each other. The second category, water cycle, speaks to both long-term chronic and short-term in acute events that can happen in terms of the climate stress. And to look through these, we can look at the precipitation trend. Now, we use precipitation because for some properties, precipitation happens as rain, or it can happen as snow, or something in between those, or it can happen as hail. And so there's a number of different descriptive words that you'll see in this widest column here that can speak to the ideas around rainfall and long-term changes in the amount of rainfall. The second of these is intense precipitation events. So as you see on the very right-hand side, this is an acute event. This can be extreme rainfall, rainstorms, related to cyclones or typhoons, hurricanes, as they are also known. And so those types of rainfall events. There's also the concept of flooding, and flooding happens as an event. So again, it is considered an acute time frame piece. Flooding can be because of rain coming down. The rain falling results in localized flooding. That's the pluvial word that's shown here. That's rain falling down in this location. Fluvial flooding is when a river or a creek would overflow, and because of water happening, rainfall happening somewhere else, or snow melt happening somewhere else. So here the idea is that the distinction here is pluvial is that rain, the flooding happens because water is coming from the sky. Fluvial is because the flooding is due to a river or a creek overflow. Finally, within the water cycle, we also include drought, and the concept of drought referring to the severity of drought, the duration of drought, and the frequency of drought events is coming through there. We list this as a chronic, a long-term likelihood of drought as being considered in here. In the third category, wind and storms, we again look to chronic, long-term changes, and we look to short-term, acute events. And so you can see those different climate stresses listed there. How does the mean wind speed, the long-term average wind speed change over long periods? And the second, storm events, so wind storms that come in. And you'll see already that there's some potential to overlap between the storm intensity and frequency under wind and storms, together with the intense precipitation events, those heavy rainfall events. The next two coloured categories we think are not really pertinent for our discussions for Sukur, but we list them there so that you're aware of the types of climate stresses that other properties, World Heritage properties, may be exposed to. Finally, down the bottom, there is another section, and this is put in place so that we can consider climate stresses that aren't in those coloured lists, coloured categories above, but are relevant for specific properties. And so to give some examples of this, ocean acidification is a stressor linked to climate change that might be relevant for some properties. Obviously not for Sukur. However, changes in the sun's radiation, the solar radiation, may be a pertinent consideration for Sukur, as might be wildfire risk. And there are others that could come in and could have been described by Dr. Itua in the climate science summary. So be mindful that there is a place to say, hey, there's something not on your list, CVI team, and we think it is relevant here. And that's what that section is for. Focusing now on those top three categories and zooming in a little bit here to be able to see those, we also wanted to give you some ideas and potential examples of impacts that might occur to the physical environment, but also impacts that could occur on the community. And so you'll see these listed there. It may be that extreme temperature events could result in a loss of wetlands for a relevant location there, or an increased wildfire intensity. So there could be some linkages across to the physical system there. In terms of the social system, if there's flooding that occurs, then that could lead to increased anxiety and distress, even depression for the community in that location. So I want to give you a few moments just to look through some of these descriptors. You may even like to pause the video if you would like to at this stage to look through some of those examples in more detail. I'll give about 5 or 10 seconds now for you to pause the video so that you can look at those, and then I'll proceed. To put the context of how this has been used with other properties, we wanted to show to you which of the climate stressors had been identified as the most important for some of our recent CVI applications. Our CVI application for the Shark Bay, Western Australia property identified that the air temperature trend and extreme temperature events in the water, so marine heat waves, were both highly relevant to the World Heritage values for that property. In addition, storm intensity and frequency was an important element of the discussions that we had there. These were the three key climate stressors identified for this natural World Heritage property. In the north of Scotland, the heart of Neolithic Orkney is a cultural World Heritage property, and in that location, the three identified key climate stressors were precipitation trend, storm intensity and frequency, and sea level rise. For the Wadden Sea, a natural World Heritage property in the north of Europe, the three key climate stressors identified were the two temperature, the long-term and short-term climate stress resulting from temperature, and the sea level rise element. Finally, a cultural property in Edinburgh, Scotland, the city of Edinburgh, the old and new towns of Edinburgh, identified long-term temperature trend, long-term precipitation trend, and short-term acute storm intensity and frequency as being the key climate stressors most relevant. In our workshop, we will be identifying these for the Sukur Cultural Landscape. For all of these assessments, we must reflect back to and ground ourselves in the climate science that has been presented already earlier today by Dr. Itua. And you can see here how we reach into both historical climate data in the upper panel there and into future projections using the same models that are used by the Intergovernmental Panel on Climate Change. It's worth noting that our time frame for the historical observations is far shorter than the scope of possible timeframes that we look at with the modeled projections. So just to give context of the timestamps in there. Our task in our breakout groups and then coming back together in plenary, which we will undertake tomorrow, is going to be to look at each of the key values that were introduced to us in yesterday's videos by John, and look there and consider which of these climate stresses is likely to have an impact on our key values of our property. So for example, your breakout group may say these three are the most relevant for this particular key value, and for a different key value, it's these three. Now, I hope that already you can look there and see that these are not intended to be guiding your selections. I've chosen snow and ice and coastal examples, which, as we discussed before, are very unlikely to be relevant for Sukur. Well, thank you very much, folks. That is the end of this video looking at the definitions of the key climate stressors. And so I hope that if you have any questions, you'll be able to discuss those now or be able to present those in our Q&A session tomorrow morning. Bye now.